welcome to the Crazy Hat Chemist. So today we're doing another video in atomic structure and electron configuration, so let's get moving. Bam! So today we are talking about atomic orbitals and their location on the periodic table. So if you are ever looking for a home in your future, there are three things that you need to pay attention to. Location, location, location. And that's why the periodic table is the same way. It's based on location, location, location. In so many ways about the 4 quantum numbers. That's why the periodic table is organized according to the way it is. Now, of course, the primary level of organization is the principle, the atomic number of the element. But beyond that, it is the 4 quantum numbers. And you're going to see this through a series of videos. It will be plainly evident why the periodic table is organized in the way that it is. It's a beautiful thing. It is truly a thing of beauty. So we're going to get started here. So these are the S or sharp type orbitals. They include groups 1 and 2 and of course helium. Make sure you include helium in this. That's why there's that little gap there to the right of the hydrogen. That helium needs to slide on over right next to the hydrogen. Then we have the p-type orbitals. That's including this entire region over here. And anything lower than that also. Okay, and then we have the d-type orbitals. That's in this transition element region here. The transition metals are the d-type orbitals. Okay, and then we have the f-type orbitals. Those are the inner transition elements, and those are the f-type orbitals right there. Okay, so a little bit more about these, and we've actually already discussed this, but this gives you kind of a summary and puts everything together here for you for their locations on the periodic table. If it's an S-type orbital, it has an L of 0. If it's a P-type orbital, it has an L of 1. If it is a D-type orbital, it has an L of 2. If it is an F-type orbital, it has an L of 3. Okay, how many orbitals do you see? Okay, and then we're going to look at the periodic table. These are the periods on the left-hand side of the periodic table. They're labeled 1 through 7, highlighted there. Now, there's something that's special that happens with the D-types. They are 1 energy level lower. Okay, notice that you would think that it would start with a 4D, but it doesn't. It's almost like the periodic table in the S and the P region has opened up and then closed back up again, but allowed the Ds to drop back down just 1 level. Notice that there are no, there's only a 1s, but there are no 1p orbitals. There's a 2s and a 2p, but there are no 2d type orbitals. Okay, all right, hopefully that makes sense here for you. The Ds are dropped 1 level lower, so pay attention to that. That is very critical. The Fs are 1 lower level from the Ds, or 2 from the period in which they are in. So for example, if you look at cerium, atomic number 58, it is a 4F, and it is in period 6, so it's 2 less than the period, or it is 1 less than the D because it's in the 5D. Okay, hopefully that works well for you. Okay, the number of orbitals corresponding to the number of boxes are half the many of that you get in a horizontal row there. So for the S-type orbitals, I see 2 elements, 1, 2, 1, 2, 1, 2. You can fit a maximum of 2 electrons in an orbital. That's why there's 1 orbital, 1 box. Okay, for the p-type orbitals, there are 6 elements. 1, 2, 3, 4, 5, 6. Divide that 6 by 2, and you get, of course, 3 atomic orbitals. Okay, that's px, py, pz. Okay, the Ds, there are 5 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. Excuse me, there are 10 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide that 10 by 2, and you get 5 atomic orbitals. And then the Fs, there are 14, and you get 7 atomic orbitals. Again, the numbers are 1, 3, 5, and 7. Hopefully that makes sense to you. Okay, the Gs would be 9. All right, so here's some electron humor, and it does relate to what we just went over, so make sure that you understand what we just went over. Why did the electron have to leave the 2d orbital? Notice that there was no 1p, there's also no 2d orbital. Why did it have to leave the 2d orbital? Well, of course, because it had 2p, of course. Duh. Okay, that was another Crazy Hat video. I hope you enjoyed that, and I have, today, a diving bell. If you like that video, give me a thumbs up. Subscribe to my YouTube channel, and I will see you next time for more cool chemistry videos.